Alright, this video is going to be about solving convex lens problems. I have two examples here. Both of these examples are when the object is outside of the focal length. Okay, so first one here is it says there an object is placed 32 centimeters from a convex lens that has a focal length of 8 centimeters. And then there's different questions you could be asked about it. In this case, where is the image? That's a common one. How tall is the image if the object is 3.0 centimeters high, and the orientation. So a lot of times, and on my second example, I will have you draw or sketch the problem. And so once again, here is how we do that. You go ray 1 starts out parallel, and then we'll bend through the focal point and go. Ray 2 will then go through the focal point on the same side of the lens, and then it'll come out parallel. So once again, where does this end up? It ends up on the opposite side. It's upside down. It's smaller in this scenario based on the drawing, and it will be real. Okay, so there's what we know. We know our distance object was 32, our height of the object was 3, and our focal length was 8.0 centimeters, and here is what we are trying to find. So we go to our equation, start with our lens equation, 1 over f equals 1 over di plus 1 over do. So plugging those in, you'd have 1 over 8 equals 1 over di plus 1 over 32. Solve for 1 over di, so that'd be taken 1/8 minus 1/32. And when you go to solve, then you'd end up with 1 over 11, or 11, when you go di, it would be 11 centimeters. Okay? Alright, next then, we're going to look at the magnification, which is hi over ho equals di over do. It gave you all three of these, or once we solve for di, we then have all three of those. So plug those numbers into the equation, and you'd find that it's a negative 1.0 centimeters tall. And once again, here this negative sign means that the image is inverted. Okay? Alright, now on example 2, I'm going to go ahead and walk you through it using the screen. So here we have a projector lens with a focal length of 25 centimeters. Where should the screen be placed to produce a clear image of an object that is positioned 30 centimeters away? Alright, so I'm going to flip over to here, and let's write down what we know. We know that distance image is what we're trying to find. Okay, distance object was 30.0 centimeters. If I remember correctly. Yes. The focal length was 25.0 centimeters. Alright. Now, to find that, once again, we use 1 over f equals 1 over di plus 1 over do. So 1/25 equals 1 over di plus 1 over 30. So 1 over di would equal 1/25 minus 1/30. Okay, so get our calculator out, and we take 1 divided by 25 minus 1 divided by 30, and we would get that as our answer. And then to flip that over, we use the 1 over x button, and we'd find that di is 150 centimeters away. Okay? Alright, so go back to our problem here. Let's draw a ray diagram of this situation. And so in this case, I'm going to start way over here. Here's my principal axis, and we put our object over here, and that is 30 centimeters away. We're just going to estimate it to be there, and then here is our focal point right there. Okay, so those are pretty close to each other. Okay, so our first one goes parallel, and then we'll bend through there. And then our second one, you can see here, hopefully I stay on the paper, go here, and then it bends out parallel and goes like that. Okay, and so you can see in this scenario that we have a inverted, larger, and because it's on the opposite side of the lens, it is a real image. So this is like any kind of projector. You always have them upside down, and so that on the screen it ends up right side up. Okay, that is it for this video.